Hi, we are Group 4. In today's video, we are going to present one-way Anova.
Using assembly language by DOSBox and MU886.
And my name is Patrick Banjao.
And I'm Jemuel Delfin.
For our introduction, Anova, which stands for Analysis of Variance, is a statistical test that assesses potential difference in a scale-level dependent variable by a nominal level variable having two or more categories. Anova has various applications and is used by both students and researchers in various ways. The one-way analysis of variance is used to determine whether there are any statistical differences between the means of two or more independent and unrelated groups. Also, it is important to realize that the one-way ANOVA is an omnibus test statistics, which means that it cannot explicitly tell which specific groups were statistically significantly different from each other. It only shows that at least two groups were different.
So let us start our ANOVA calculator using assembly language in MU886. So our first line of code, precision is equal to 5. This will be the indication of how many decimal numbers will be output. So here are the following declared variables and messages to be used in the program, such as message 0, message 1, 2, 3, so on and so forth. Then here, this will be the variables that are to be input by the user, and some of these variables will be computed dependent on the user's input, which follows. Each of the variable will be further discussed throughout the following program. So, here we are in the first column. This part of the code will be the input of the first column. LEADX message 1 will output the message declared from the start. Then, call scan_num. It will ask for the user's input. Then, the value stored in CX will be moved to the variable num1. Put C0DH and put C0AH is considered as a new line. And then, going to JMP2 plus 1, it will be the operation responsible for the summation of the three inputs. 2 plus 1. Plus 1. So here is 2 plus 1. Stored value from num1 will be added to num2 and num3. The output will be printed using the printNum function. The sum will be stored in sum1. Then put C0DH and put C0AH will output a new line. And then the JMP next will go through the next step, which is indicated here. Here, which is the second column. So for LEADX message 2, this will be the same as the LEADX message 1, which will input a number from the user. So for the second and the third column, it does the same function as the first columns, but it will be stored, the data will be stored into their respective variable, which is stated in the code, such as num7, num8, num9, and etc. So for our next operation, which will be the square of sum1, this operation will take the square of sum of the first three integers input by the user. Do mode will be responsible for this operation. So do mode will be here. The value from sum1 will be multiplied by itself with the use of IMU. Then calls the printNum function operation to output the number. Then the value from AX will be stored to the variable SQ1. So this will be the same for the square of sum2 and square of sum3. Next will be the sum of three squares. This will take the three values from the square of SQ1, 2, 3, then add together. Do plus 4 will be responsible for this operation where the value from SQ1 will be added to SQ2, which can be found here. The value from SQ1 will be added to SQ2 and added to SQ3. Then it will call the printNum function to print the corresponding output. Then the value will be stored in SOTS, which is in short for sum of three squares. Now, for the next operation, which will be the summation of all n's, which is here. The summation of all n will take all the user inputs and add them all together as seen in the code. Num1 will be added to num2, num3, num4, and so on and so forth. The sum will be squared using the IMU operation, then print out the value by printNum, and store the value in SQSum. Then this will go to jump next 7, which will be for the division part. Now we are in the division part where we use the value of SOTS and divide it by 3 since it is stated in the formula. Notice that print float was used to output a decimal number since it is division. So now we are in the result of SS between. The result of SS between is calculated by subtracting SS1 and SS2, which was calculated in the division part here. The output will be stored in SS between, and it will be printed using the print float function as it is a decimal value. So now we are in next 11, will be the operations to compute needed the values in SS14. In this operation, this takes every input by the user and squares it using the operation IMU and stores the proper variables, which are square 1, square 2, square 3, and so on and so forth. Then all these values will be added together using the add operation. The output will be stored in square tot. The value will be printed using the printNum function, as it does not require a decimal value. Now we compute for the result of SS within. To compute for the SS within, which takes the value of square tot and SS1, then subtract them and store it to SS within. We use the printFloat function to output it since it is a decimal value. Now for lastly, the result of SS total. It can be computed where square tot and SS2 are subtracting from each other using the sub operation, and output using the printFloat.
So the MS between will compare the DF bet to 0. So if the jump not equals soluble 2, so it will be moved to the soluble 2, and then the SS between, the value of the SS between will move to the AX, and then X or dx to 0 for 0. And then compare the AX if it's 0. And then for this one is the denominator of the MS for the MS between, which is the DF bet. And for the value of the DF bet, it would be in the value, as you can see here, DF bet would be equal to 2. So the value for SS bet is divided by 2, and then as you can see here, Leia DX message 25, and then for the message for this is the MS between, the string for the MS between, and then it will call the string, and then pop DX, and then print the float, which will be printed by the operator below. Then the value will move from AX to MS between, and then the put C 0DH and put C 0AH will be the new line. And for the next jump, next 15, and then it will be moved to next 15, which is the MS within. So it will compare the diff to 0 if it is 0. So if jump not equal soluble 3, then soluble 3 will do the procedures move AX, then the SS within will move to the AX and then X or dx so that it will be 0, and then compare AX if it is 0, and then for this one is move BX DF diff. This could be the denominator for the MS within, so it will be moved to the BX and then divide by the BX, then push to DX, so it will be divided, and then Leia DX is message 26 is for the string, for the total of MS within, and then it will call the string from the message 26, and then it will print the float, and then the value for the MS within will move to the MS diff, and then the MS diff, and then the value for the MS within is stored in the variable of MS diff, and then do the procedure again for the new line for the next procedures, so, because it will jump to next 16, and then next 16 is the MS total, same with the procedure as what MS within and MS within does, and then df dot compared to 0, so if it is jump not equal, it will be proceed to soluble 4, and then the SS total will be stored on the AX and do the X or dx, so on and so forth, and then df dot will be stored in the BX and then will be divided by BX, because since df dot is the denominator for the MS total, which is the value for df dot is equals to 8. So as you can see, Leia DX message 27. The string for the message 27 will be called the string output, then pop DX, and then we'll print the float. For for the MS total, and then the value for the MS total will move to the variable MS dot, and then do the operation for new line, and then it will be jumped to next 17. And for the F total, the MS diff, which is obtained from the last procedure, and then it will compare if it is 0, and then so if jump not equal, it will be proceed to the soluble 5, and then the value for the MS between will be moved to the AX, and then do the operation for the X or the XDX. So it will be 0 for the X. So it will be compared, then move to the not sign 5, and then the value for the MS diff will move to the DX, and then will be divided since the MSDF is the denominator. Then push DX, and then Leia DX, message 28 is the string for this operation, and then will be called the string print, and then pop DX, and then call the print float, which is the proc, and then the value will be moved to the AX also, so that it will be moved to the F dot, and then do the operation for the new line. Since after that it will be next 18. So the next 18 is the X mean. So in this operation, the div2, which is already declared above, div2 dwd2, because since this is a as you can see here, X mean, the value for num1, num2, num3 will be moved to the AX each, and then do the same operation as MS between, MS within, and MS total does. And then move BX div2, and then it will be proceed to the message 29, and then call the string for message 29, and will be call the print float for printing the number with decimal, and same operation with the Y mean. But in this, we declare for num4, num5, num6 for each number that is entered by the user, and will be stored in AX and jump to the not underscore sign 7. So with the same operation of the X mean, it will be print float, and then move the resulting value, since it is from AX, and then move to min2, so it will be called later. And then for the Z mean, next 21, compare div2 JNE soluble 8, and we'll move to the soluble 8, and then the num7, num8, num9 store to the AX, and do the X or DX DX, so it will be 0, and then call the string message 31, and then print the string pop DX, and then also print the number with decimal, and then do the line. For the graph, this one is for the calling the graph message, since we're going to have a mouse operation and keyboard operation, so we must call for graph message as what in this is for the to graph message. Press any mouse button to graph. So just press the mouse button to after resulting the value, just press the mouse button to proceed for the graph. And then move AX 03H, and then in 33H, and then for this one is the video operation, so it will be the DOS box will move to the video operation int and h, and then this is macro, write string value in here, move in this one. As you can see, the first value is the string, which is the outputted string, and then the length of the string, for example, high. So the length of this would be 2. Then the x and y, this would be the row and column. So as you can see here, write string value 150. Since it is a 150, as you can see here, declared above. So value 150, as you can see, 1, 2, 3, 4. So the length for this one is 4, which is already declared by this. And then this 2 is for the x, which is the row, and then y is for the column. And 00VH is the color of the string, if what color do you want, which would be seen in the BIOS BIOS color. And for this one, value 0, same with the value 150, value 75, and for this one, value 1, this could be the x. Value 2, this is the y, and value 3 is the z. So for the draw, this is for drawing the graph with the bar graph. As you can see here above, we call a draw macro RR, RC, LR, LC, color, and then local start again. For RR, this is where the row starts, RC, where column starts, LR, where row ends, and then LC, where column ends. So as you can see here, this is the RR, RC, LR, and LC. So in this one, this would be the vertical bar graph in the given result, and this is the horizontal bar graph, which is the value only for the video operations is 200 by 300. So if we're going to run the file, we just type the file in the DOS box, and then our file, since our file is already TASA, and the file name of our project is try2. Then, as you can see here, we're going to enter the first number, which is the num1, the variable in that program. So, for example, we're going to put 45, but for example, we're just going to delete, and then if I'm going to type a letter, it will be that type, since our program is used only for typing a number. 4, 4, 2. As you can see, 4 plus 4 plus 2 is equals to 10, so it will be the sum of 10. 2 plus 3 plus 1. 6, 5 plus 6 plus 2. And then the square of sum, as you can remember, the sum of the first column is 10, and then the square of 10 is 100. Square of the second sum is 36. The square of the third sum is 169. So the sum of the three squares is 100 plus 36 plus 169 is equals to 305, and the square of n is the values for each variable, num1, num2 until num9, and then the total of it and then it will be squared. The value for this resulting value is 841. And as you can see, there is a result of SS between, SS within, and SS total. And then the MS between is depends on the SS between, as long with the MS within depends on the SS within. So the MS total, it depends also the SS total and the F total. So the F total is equals to 2 since our value for the from the table is 5.143. So the value is failed to reject the null hypothesis. Since it is less than 5, so it is failed to reject. But if it is higher than 5, accept the null hypothesis. So our x mean would be 3.3333, and then our y mean is 2, and z mean is 4.33. And then if I'm going to press the mouse button, and then it will be proceed to the video operation. As you can see here, this is the values that we've entered from the user for 231562, and the value for the graph of this graph is the mean values for these values for the x, y, and z. As you can see, it is small since our values is small. But this program can do operations until 150. If I'm going to type a since it says here that press any key to exit, since this is our project for one-way Anova, COE119L P2.
The program also is capable of graphing, and the program is also equipped with the keyboard and mouse interrupts, courtesy with the bias interrupts. The program also implements various interrupts like in21H, in10H, and in13H. Overall, we have successfully compressed the complex calculation of one-way analysis of variance into almost 1,600 lines code written in assembly language.